Hi everybody. So this is a lab that we were supposed to do in person. So this is called determination of the molar volume of a gas and the universal gas constant. Make sure that you've printed off a copy of the lab before we get started. All right, there's an introduction that you should read. It talks about some things that you really need to understand. I did make some changes, so just kind of follow along. Make sure these will all be changed on your sheet, so you should be able to see all this. Right, so just follow along as we go. I do have everything that we need here, I think. All right, so let's go ahead and get started and give this a shot. So under the procedure, we're going to start right from there. All right, so fill a 1,000 milliliter beaker about 3/4 full with tap water, and I've already done that. So here's the tap water. Okay, just gonna put that over here. We are going to need the temperature of that in a few minutes. It is room temperature because it's been sitting for a few days. So the next thing that we need a piece of ribbon, and we want 2.50 centimeters of magnesium ribbon. And we want to be as exact as we can. Right, so here's my magnesium ribbon, and you've all worked with it before. I'm going to lay it out here. I'm going to mark it. And you can just cut it with a pair of scissors. Right on that mark. And there's my 2.5 centimeters. So we can go ahead and put that out of the way. And okay, so there's that's number 1 under the procedure. So number 2 in the procedure says we want to make this. This is a stopper, and it's called a 1-hole stopper. And I have a piece of copper wire with a little loopy thing on here. And what we have to do is we have to secure this piece of magnesium ribbon to the loopy thing on the copper wire. We don't want it to come off. All right, so, and if you're not careful, the magnesium ribbon will break. So we don't want that. So I'm just going to kind of wrap it around here carefully. Come back around here a little bit. Wrapping it around this copper, we want to secure it the best that we can. And that's not too bad. So it should, I know it's kind of hard to see, but hopefully you can see that we've secured this piece of magnesium ribbon right to that little thing there. And that's procedure number 2. And if you turn the page, okay, we're going to need 100 milliliter graduated cylinder. Okay, it says 10, but we want 100. I've already cleaned it. All right, and we're going to add about 15 milliliters of 3 molar hydrochloric acid. So here's my 3 molar hydrochloric acid. We're going to add 15 milliliters. Pretty good. And then what we're going to do is we're going to add some distilled water. Okay, and I want to actually do this on this tray. Okay, so we're going to add some distilled water, and we're going to fill this all the way up to the top with distilled water. And then as soon as we have it all the way to the top, what we're going to do is we're going to take the stopper with the magnesium ribbon. We're going to place it into here, and we want water to come out because we want no gas caught in here. All right, and we're going to push this down just like this. And as soon as we have that in there, we're going to take this graduated cylinder and we're going to invert it and put it in here. And we don't want any gas to get in there. right? And the magnesium is going to react with that hydrochloric acid to produce hydrogen gas, and we're going to collect that gas over water. So that's what we're doing here. Right? So let's see if we can do this. We want to do it pretty quick. Let's get this out of the way. So we're going to add this all the way up to the top. And water is it's going to end up spilling, and that's okay. That's why I have this tray down. So I'm going to take this stopper, we're going to put it in there, all right, and then we're going to quickly invert it and put it into here. So here we go. We're going to put this in here. We're going to quickly invert, all right, and we're going to let it sit. Now, what I want to do is I want to bring you in closer, I think. Let's see if we can take this off. I'm going to bring you over here so you can kind of see what's going on. Hold on. Here we go. All right, so we're going to zoom in over here. And I'm going to come down here so you can see. All right, and if you look carefully, the hydrochloric acid is reacting with the magnesium ribbon. Now the acid does not react with the copper, all right, so it's producing a hydrogen gas, and that hydrogen gas bubbles to the top, all right, and we're going to collect it over here. And then we're going to be able to measure the volume of this. Okay? Now this is going to take a little bit. All right, so we're just going to let this run. Right, and while we're letting it run, I have to do a second trial, so I'm going to go ahead and set up my second trial also, right, just so we have two of them going on at once. Right, now, we just let this go until all the magnesium ribbon is reacted. All right, so here we go. I'm going to put you back over here. Sorry. Having trouble here, having trouble. There we go. All right. And I already have, okay, so here's another graduated cylinder. All right. Woo! I've already made our loop with our magnesium ribbon. Okay, so that's already on here. I'm going to put that right here. I have another beaker, and it again is the same exact temperature as the water over here, they're at room temperature. So we need 15 milliliters of this guy. Add our hydrochloric acid. That's pretty good. Put this on here. We're going to add our water. This is our distilled. We want it to go all the way to the top. Put it in here, overflows, then we're going to invert it, get it into our water, all right, and it will start to react. Okay, so now we've got two trials going on. We have trial number 1 and we have trial number 2. All right, so we can see what's going on. Why don't I bring you back down so you can kind of see it a little bit closer from a different angle. closer to trial number 1, you can see that we're collecting that hydrogen gas right here. Okay, so we're collecting that hydrogen gas there. All right, and if we look down towards the bottom, you can see that it's still reacting with that magnesium ribbon. All right, and if we look over here, this is trial number 2, and it's starting to collect some gas, but it's also reacting. All right, so you can see that magnesium ribbon reacting. So now we just need to let both of these go to completion. Okay. Now, while we're waiting, we need a couple things. All right, so first of all, we're going to need the temperature of this water. Okay, we need the temperature of that water. All right, so I'm going to bring it back over here. And I'm going to mount you back up here on the tripod. We're good. Oh yeah, we're good. So we need the temperature of this water. Put this in here. Now, let's kind of talk a little bit about what's going on here. So, eventually what we're trying to calculate is that universal gas constant. We're going to be using the universal gas law. We're going to use PV equals nRT. Right? And what we're doing is we're collecting a specific amount of hydrogen gas, okay, and we're collecting it over water. So technically, this is a mixture of gases, and we can use Dalton's law to figure out the pressure of the hydrogen gas inside that container. So this is a mixture of hydrogen gas and water vapor. All right, now what happens when we collect gas over water is some of this water evaporates, right, and it produces water vapor above it. And the amount of water vapor that's produced is dependent on the temperature of that water, right? And that's called the vapor pressure. Okay. So we can, as long as we know the temperature of this water, okay, we can figure out the pressure being produced by the water vapor. Then if we know the total pressure of what's inside this container, we can subtract off the pressure produced by the water vapor, and that will give us the pressure produced by the hydrogen gas. And once we have that, we can use that to put into PV equals nRT. And we'll have a pressure. We will also have a volume. We'll be able to measure it. Right? N is the number of moles, and we can calculate N, the number of moles of gas, by stoichiometry and the reaction between the magnesium and the hydrochloric acid. Okay, we'll have our temperature, okay, because that's what we're measuring now, right? And then once we have that, we'll have P, we'll have V, we'll have N, and we'll have T, and we'll be able to calculate that universal gas constant. Okay, and we're going to do it twice. All right, so let's go ahead and get our temperature of this water. And the temperature looks like it is about 18.1. Okay, so the temperature of the water, and there's a data table. Oops. Okay, there's a data table. Is 18.1 degrees Celsius, right? And it's on page, I don't know, if you scan through you'll find it, right? It says page 143 at the top, all right? But you'll need the temperature of that water at 18.1 degrees Celsius. And just for fun, I'm going to bring this over here and make sure that it's the same. So let's let that sit in there for a minute. And the reaction is still going pretty well. We still have quite a bit of magnesium ribbon left in trial 1 and in trial 2. Right? So those are just reacting away, and we're producing that hydrogen gas. And it's really just a waiting game right now. while we're waiting, I'll bring this down just so you can see it again, get a little bit closer. Oops. Okay, and you can see that we're collecting that gas above, all right, so we have a pretty good, okay. And the water, hydrochloric acid, that's being displaced down as we collect this gas. Okay, and the same thing's happening in trial 2. Right, but they're still reacting pretty well, so let's see if we can zoom in a little bit here so you can see. Okay. Yeah, and you can see that that magnesium ribbon is still reacting with the hydrochloric acid and producing the gas, and it's reacting pretty well. All right, so we're just going to let that sit. And the same thing's happening over here in our trial 2. And we do need to get that temperature. So I'm going to put you back and we're going to check that temperature to make sure it's the same. And if I read this temperature of this water, it is exactly 18.1 also. Right, so the temperature of our waters are both exactly the same, which is what we want. And now we just got to kind of hang out until all that magnesium has reacted. And that's just going to take some time, so let's just let this run. And we will come back in a couple minutes. checking in here. And looks like we're still reacting. Okay, not a lot left in trial 1. And trial 2 is still going. Trial 1 is finishing up. It's still bubbling and we still have gases. All right, still going. We gotta let it go the whole time. I'm gonna put it straight up and down here. See if we can balance these. Leave those for a little bit. And we'll just let them run. How are we doing over here? Yeah, let's see how trial 1 is doing. And it's almost done. Now there's some bubbles in here. We want to tap this and see if we can get all the gas to rise. All right, now, okay, so trial 1 is pretty much ready. Trial 2 is not quite. Right, so what we have to do now is we need to figure out the pressure inside this container, inside the graduated cylinder. And we can do a neat little thing, okay, because of the atmospheric pressure. So I looked up the atmospheric pressure, and what was it today? Today's atmospheric pressure was, and I'll have this written down for you, 759.71 millimeters of mercury. Okay, so that's the atmospheric pressure. That's what's pushing down on the water right now, on the surface of the water. Now, if I equalize the level of the water inside the graduated cylinder with the water level here, what that does is it makes the external pressure, the atmospheric pressure, equal to the total pressure in there. So what I'm going to do, and I'm going to have to move things around a little bit. Well, let me show you. So I have over here, this is just a big cooler, and it's full of room temperature water. So it's the same temperature as the water over there. Right now, what we're going to do, and let me see here. Can you see? Now, let's just bring this over here. Woo. Okay. That's not bad. See if we can zoom in a little bit. So, what I'm going to do is I'm going to carefully transfer, okay, this graduated cylinder over into the big bucket of water. And then what I can do is I can lower and raise the graduated cylinder until the water level inside the cylinder is equal to the water level in the cooler. Right? Now, we want to be really careful when we transfer that we don't lose or let anything, any gas or anything into the graduated cylinder. Right? So let's see if we can go ahead and do that. Zoom in a little bit more so you can see what I'm doing. All right, and I realize that you're not going to be able to take the volume reading, all right, but I will take that for you. All right, so so let's go ahead and do this transfer. This is trial 2. Right, so what I'm going to do is I'm going to reach in here and I want to cover up this hole, and we're going to go as quick as we can, right over here. Right now I got to adjust this. Okay, we need to adjust this so that the water levels are the same. So I got to bring it down here, right? And when they're the same, okay, that's when we get the atmospheric pressure equal to that total pressure in that container. All right, so I got to play with it a little bit, and it's kind of hard to see. All right, so now my volume of that gas in there that we produced looks like it's about 44.9. Okay, so trial 1's volume is 44.9 milliliters. Okay, so now that I have that, I'm good to go with this guy, and I can take him out. So he's all set. There's my trial 1. Right, now, let me look here and see how we're doing with this one. Tap it a little bit so you can get some of this gas up here. Looks pretty good. Right, now we need to do the same thing for this one. Okay, so we're going to transfer this over here. We need to equalize that pressure because we want that atmospheric pressure equal to that total pressure in there. So I'm going to carefully put my finger in here, quickly transfer. And I'm going to play the same game as we did before. Right, and it hopefully is right around 45. Right, let's see what we got. And it's actually just a little bit more this time. So it looks like my volume for trial 2 is going to be 45 point, it's just over 45, so 45.1. So my second volume for trial 2 is 45.1 milliliters. Okay. Now that we have all of these readings, now we can go ahead and we can actually calculate our universal gas constant. All right, so now, PV equals nRT. Our pressure is going to be our atmospheric pressure, which we said was, I don't know, can't remember what we said, 759.71, minus the vapor pressure that water produces at this water temperature. And you're going to have to look that up. Okay, you're going to have to look that up on the internet, nice and easy. All right, so that will give us our pressure. The volume is the volume that we just measured. So there's PV. N. N is the number of moles. And you have to figure out, we're going to use stoichiometry to figure out how many moles of hydrogen we produced. All right, so we look at the equation of the magnesium reacting with a hydrochloric acid. All right, we write out that single replacement reaction.